again, third grade students and families. Thank you for tuning in. Welcome to Week 10, Lesson 2 for the week of May 18th through the 22nd. This video is to support schools using the Bridges Math program. My name is Miss Greenwood, and I'm hoping that today's lesson will help shape our thinking with classifying and sorting shapes using attributes. Materials that can support today's learning include pencils, scrap paper, and toothpicks. Yes, I did say toothpicks. So if you happen to have some around, go ahead and grab them, and I'll show you later in this video how they can be used as a math tool to support today's learning. Let's get started, shall we? In our previous lesson earlier this week, we practiced classifying and sorting polygons. A polygon is a two-dimensional figure that is closed and has straight sides. We use attributes to name polygons. An attribute is a specific characteristic or quality that a person, place, or thing has. Today's learning will be focusing on a specific group of polygons with 4 straight sides and 4 angles. Do you remember what we call those polygons? Yes, that's right. They are quadrilaterals. So today's learning objective is as follows. We will identify quadrilaterals using attributes that define each type of quadrilateral to better understand shape attributes. Think about it. Same but different. Earlier, I mentioned using toothpicks as a math learning tool because they are great for building polygons. Right now, I'm going to build 2 polygons using toothpicks. Think about what you are noticing with the 2 polygons that I build. What is the same and what is different? What are you noticing right now? What is the same? What is different? We know both of these shapes are quadrilaterals because they share common attributes of 4 straight sides and 4 angles. When we take a closer look, we will notice other attributes that they also have in common. Both have 2 pairs of parallel sides opposite each other. Parallel means always the same distance apart. When we take a look at their 4 angles, all 4 angles are considered to be right angles or 90 degrees. So that is another attribute that they have in common. Both these quadrilaterals are similar because they have 4 right angles and 2 pairs of opposite parallel sides. However, there is a difference. When we take a look at the quadrilateral on the right, I'm noticing something about the sides. Do you see it? Yes, all 4 sides are congruent or equal in length. So these 2 polygons or quadrilaterals are different because the quadrilateral on the right has 4 sides equal in length. When we compare and contrast polygons, it's important to notice the attributes they have in common as well as attributes that they don't have in common. All quadrilaterals have in common 4 straight sides and 4 angles. However, there are some quadrilaterals that have additional attributes in common. We can sort quadrilaterals into different categories based on these specific attributes. Let's look closely at the different types of quadrilaterals. Parallelogram, a quadrilateral with 2 pairs of parallel sides opposite each other. Rectangle, a parallelogram with 4 right angles. Rhombus, a parallelogram with 4 congruent sides. Congruent is another word for equal. Square, a parallelogram with 4 congruent sides and 4 right angles. So what is the attribute that all 4 of these quadrilaterals share beyond having 4 straight sides and 4 angles? Yes, all of these special quadrilaterals have 2 pairs of parallel sides opposite each other. What about the square and the rhombus? Do they have a special attribute in common between them? Yes, they both have 4 congruent or equal sides. However, we can tell the difference between a rhombus and a square because of the kind of angles each has. Remember, a square has 4 right angles, and that's how we can identify squares from rhombuses. In fact, when we compare quadrilaterals, we need to take notice of attributes that they share as well as attributes that they do not have in common. There's another type of special quadrilateral called a trapezoid. How is a trapezoid different from a parallelogram? Remember that a parallelogram has 2 pairs of parallel sides that are opposite one another. We call any quadrilateral that has at least one set of parallel sides a trapezoid. Now we are going to use the Pattern Shapes Math app from the Math Learning Center to take a close look at this group of quadrilaterals that we see pictured here at the top. Our question at the bottom reads as follows. Cross out the quadrilaterals that are not squares. So we're looking for quadrilaterals that are not squares, and when we find them, we're going to cross them out. So any quadrilateral that we find that is a square, we are going to leave alone. Let's think about what we know about squares and their special attributes. Let's start with angles. All quadrilaterals have 4 angles, but not all quadrilaterals have 4 right angles, like a square does. If you can picture that corner, which makes up the angle of a polygon, we should be able to see and picture there a little mini square. That lets us know that it is a right angle that measures 90 degrees. So let's start looking at each of these quadrilaterals, moving from the left to the right, and let's see which of these quadrilaterals have 4 right angles. If they have them, we're going to leave them alone. If they don't have 4 right angles, then we're going to cross them out. So this orange quadrilateral here on the left does have the 4 right angles. This blue quadrilateral, however, does not, and neither does this red quadrilateral. This quadrilateral here does have the 4 right angles, but this quadrilateral here on the right-hand side does not have the 4 right angles, so we can go ahead and cross it out. Now we should also think about the sides and think about whether squares have any unique attributes in regards to their sides. And they do. They have 4 equal sides. So now, when we look at what's left in our group that we haven't crossed out, we can now cross out the quadrilateral here on the left, because although the right and left sides appear to be the same length, the top and the bottom sides are a different length compared to the right and left. So we're going to go ahead and cross that out. So here we are noticing the 4 equal sides, so this must be our square within this group. How is a parallelogram like a rhombus? How is a parallelogram different from a rhombus? We're going to create some labeled sketches to help us think about what is the same and what is different when we're thinking about a parallelogram and a rhombus. First, I'm going to sketch my parallelogram. A parallelogram has 2 pairs of parallel sides that are opposite each other. Remember, parallel means the same distance apart. So I'm going to try to be as precise as I can with my sketch. If you happen to have a straight edge at home, that would be a great tool in creating your sketch. Next, I'm going to sketch the rhombus. Now, the rhombus is similar to the parallelogram because it too also has 2 pairs of parallel sides that are opposite each other. However, a rhombus is different from a parallelogram because all 4 sides of a rhombus are equal in length. So, a parallelogram and a rhombus are alike because they have 2 sets of parallel sides that are opposite each other. They are different because the 4 sides of a rhombus are congruent or equal in length. Okay, now it's your turn to try it. You will complete page 191. In the first section, you will identify some of the attributes that we discussed today in the quadrilaterals that are being shown below. Read each bulleted instruction carefully. In the next section, at the bottom, you will review multiplying factors and finding products. Wow, you all did amazing today. Air high fives all around. Until next time, 3rd grade scholars, take care, stay safe, and stay connected.